Hi, this video I'm going to cover some more big O notation, analyzing some different types of algorithms and things. We're going to start off with analyzing lists. So in this one, there's two common operators. Operations are indexing and assigning to an index position. Both of these operations can take the same amount of time no matter how large the list becomes. When an operation like this is independent of the size of the list, they are O1. Another very common programming task is to grow a list. There are two ways to create a longer list. You can use the append method or the concatenation operator. The append method is O1. However, the concatenation operator is OK, where K is the size of the list that is being concatenated. This is important for you to know because it can help you make your own programs more efficient by choosing the right tool for the job. Let's take a look at four different ways we might generate a list of n numbers starting with 0. First, we'll try a for loop and create the list by concatenation. Then we'll use append rather than concatenation. Next, we will try creating the list using list comprehension. And finally, and perhaps the most obvious way, using the range function wrapped by a call to the list constructor. Okay, so let me pull up get a blank file here going. There we go. Okay, so we're going to do all these at one time here. So I'm going to import time, or actually time it, and then from time it, I'm going to import timer. Right? So this is going to help us do this analysis in here. So test one, we're going to create a list called lyst is equal to an empty list. And then for I in range 1000, we're going to do list equals list plus, plus, and then bracket I bracket. So we're going to add another item to the list. Okay, that's our first one. Second one is we're going to do test 2. Oops. So in test 2, we're going to create a list again. And then for I in range 1000, list dot append I. Test 3, list is going to be equal to, and then in brackets I for I in range, oops, 1000. Spell this right, lyst. And then test 4 is going to be list equals list range 1000. Okay. So what we're going to do is we're going to use this timer that's built into Python to kind of give us a test run on this. So I'm going to create a main. So in this, we're going to create T1, stands for test 1, call timer. And here then, we're going to do test 1, parentheses and parentheses, and then from, underline, underline, oops, got to get a space in there, main, underline, underline, import test 1. Then we're going to print. This was concatenation, so do that CAT, T1 dot time it, and then we're going to pass in number equals 1000, and then milliseconds. Then our T2 is going to be equal to timer, test2, parentheses and parentheses, dot time it. Oops, I'm in the wrong location there, sorry. Test2, comma, and then from, underline, underline, main, underline, underline, import test2. Then we're going to print. This one is append T2 dot time it, number equals 1000. Milliseconds. T3 equals timer, test3. From main, import test3. This one is the comprehension. T3 dot time it, number equals 1000. Milliseconds. And then T4 equals timer, or timer, test4. From main, import test4, and then we'll print that one out. And this one is the list range. Okay, and then we'll just call main, and I'll get this saved here. I'm going to save this as test list.py. And put this in our solutions there. And let's see how this runs. Error. Misspell range in for I in range. Let's be up higher here. Let's see here. There we go, right there. Another error. Test2 parentheses. Missing and closing parentheses or something. Right there. There we go. Try it again here. There we go. So concatenation takes 0.18 sort of milliseconds. Append takes 0.13. Comprehension takes 0.05. And list range takes 0.02. So based on that, list range would be the best one, comprehension the next, then append, and then concatenate. So it kind of gives you an idea of depending on which way you put the data into the list, is how it's going to handle that. Um, so let's go ahead and do a different one now. And let me get set up here. Okay, so when you're working with lists, you use pop to remove an item from the list. You have pop, which removes it from the end, and you have pop zero. Well, you think, well, what's the big deal? It just takes it off one end or the other. Well, the difference is if you take it off the end, there's nothing that has to be adjusted. If you take it off the beginning, off zero, then everything has to be shifted up one. And so that's what we're going to look at here and see how this is. So let me pull my information up here. I'll get a file started. There we go. Okay, so get a new file started there, and then we'll take a look at this and see how this works from there. So give me just a second. Okay, so let me squeeze this down here. Whoops. Come on. Get rid of this one. Don't need it anymore. And we'll do this next one here. So we're going to import TimeIt again. And I'm just going to do this without a main in here. So we're going to do a pop 0 is going to be equal to TimeIt dot timer x dot pop 0, and then from main import x. Okay, so what we're telling it here is we're going to create a list for a certain size, and then that's going to be stored in x, and so that's going to be the x dot pop 0, and then we're going to import x on here to do that. So we're going to do a pop end. It's going to be equal to TimeIt dot timer x dot pop with no 0 in it this time because we're doing it from the end. Same information on there. So we're going to print, and I'm going to do it the way I have it here. It's an old way of doing this, but okay, so percent 15s space percent 15s space percent, and then in parentheses the pop 0, yeah, in quotes. I'll have to quote mark off someplace. Right there. And then pop. There we go. Okay, so that's the heading for it. And then we're going to do for I in range. And we're going to start off with 1 million. And then we're going to go up to, let's see, 1, 2, 3, 4, 5, 6. So 1, 1, 2, 3, 4, 5, 6, 1. And then we're going to increment it. 1, 2, 3, 4, 5, 6, a million at a time. Okay. We set x equal to a list range I. And then we're going to do pop 0, which is going to be our PZ is equal to pop 0 dot TimeIt number equals 1000. And then we're going to do x equals list range I. And we're going to do PT equals append, whoops, sorry, wrong one, equals pop end dot TimeIt number equals 1,000. Okay, so then we're going to print this out, and again, I'm going to use the old way of doing this because I didn't change this in my notes. 15.5f, and then percent 15.5f, and then a percent, and then in parentheses, pz and pt. Okay, that's the program. We'll go ahead and get this saved. Say this as pop analyze.py, and then let's go ahead and run this and see if I got any errors in this one. Okay, so there we go. So you can see on here so far, pop 0, first one took 1.5 seconds, second one took almost 3 seconds, next one took 4.5, next one took 5, or not a half, 4, so anyway, back up. Took a little over 1, then 2.5, a little over 3, a little over 5, a little over 6, a little over 7. Notice on the other side, they're staying pretty close to the same thing. 0, 0, 0, 1, 8, 1, 3, 1, 0, 0, 8, 13, 8, 8. Okay. So as the number increases on how many we're processing, the pop 0 takes more time because, like I said, you take one out of the 0 position, all of them from 1 down to the end have to be shifted up 1. Take one off the end position, nothing has to be shifted. Okay. So 2, 3, 4, 5, 6, 7, 8. Looks like 1, 2, 3, 4, 5, 6, 7, 8, 9. There should be one more on there. There we go. There's 12. So doing this for that large number there, getting close to 100,000 or 100 million, is 12 seconds. So it takes quite a bit more time than doing it from the other end. So that's what you have to look at on your algorithms that you're doing, on which one would be the best one for the problem that you have. Okay. So I'm going to stop here with this video. Hopefully this helps you out on helping understand why it's important to analyze your algorithms. Bye.